Here I'll be demonstrating couples. A couple is a force applied at a point here A, and we have the negative of that force vector applied at a point B. And the couple is actually the combination of these two forces and the distance between them. So we can, here we can change the force and see how that goes. And we can change the positions of A and B and see how that goes. And we can enter the values up here if we want to be more specific and make the values nice. 1 minus 1. Okay, this couple is really, again, the combination of these, the moment generated by these two forces. So, usually when we do a moment, we try to eliminate one of the forces. So I'm going to calculate the moment about the point B. So I calculate the moment of this about point B. So it's really just the position vector. This is r, the distance, of A with respect to B. And we cross that with our F vector. And here we see we get minus 8 in this case. So that's our couple value is minus 8. And here we don't, we can change the distance wrong one. We can make the distance bigger and the force smaller. So I doubled the distance between them, and we'll make the force smaller, and we still end up with minus 8. So the couple is really a combination of the distance between these forces and the magnitude of the force, but the couple itself can be a single value. Okay, we can also calculate this couple based on the perpendicular distance. So again, we draw the line through the negative F vector and use the perpendicular distance. So the perpendicular distance times the magnitude of F gives us 8. And we notice here with our right-hand rule that this is really a negative 8. Put our fingers from the P vector to the F vector and our thumb points into the screen, so that's a negative 8 value. The real interesting thing about the couple is when we go about another point. When we go about another point, here the origin, we have actually two moments. We have a moment generated due to the F vector and a moment generated to the minus F vector. And here we have R of the point A relative to C and the position R of B relative to C. And we see here that it's still minus 8. So I can move the point C here anywhere, and that'll change these two vectors, but it doesn't change the couple. The couple value is still minus 8. And for that reason, really, when we apply a couple, it's effective, clear all over the rigid body. So it doesn't change wherever we place it on the rigid body. It's still the same magnitude and direction couple. This also works in 3D, but it's easier to show here in 2D. We could just do a plane through the two vectors and have it in 2D anyway.